Okay, folks, this question goes with your web assign. I believe it's question number 12. And I'm not going to do the first part. I've already done it. But I want to show you sort of a hint for how to do the second part. So in this problem, we were given the non-homogeneous ODE y double prime minus 4y prime plus 3y is equal to x. And then we were given one solution to the corresponding homogeneous ODE, y1 equals e to the x. So the first part asked me to find a second solution. I did so using the techniques taught in class. I found that a second solution to this would be y2 equals e to the 3x. Just so you know, going forward, since the coefficient functions are all constants, it turns out there's actually a really easy way to find the solutions to this second order ODE, and we'll talk about that next time in section 4.3. But anyway, you could certainly use the techniques we taught in class, and so I was able to find a second solution to this. Now, the next part is a little bit harder, I think, and it asked us to find a particular solution to, and sorry, I had that originally written wrong, to find a particular solution to the corresponding to this particular corresponding non-homogeneous ODE. So this involves us just sort of eyeballing a solution, and that's sometimes easier said than done. So that's why I'm making this video, is because I want to review this, or cover it. So the book didn't give any techniques for just eyeballing a solution, so I want to show you what I did in trying to come up with it. My first guess is to see if I could find a constant solution, because that's the simplest solution there is. Let's try y equals a constant. Well, you know, I take the first, second derivative, I'd have an expression like this. There's no way, if I have a constant solution, that I'm going to end up with an x on the left-hand side of this. So on this left-hand side, as I take various derivatives and multiply by constants, there's no way I'll get an x over here to equal the x over here. So that won't work. So the next guess, and this is sort of I think this is a good strategy for working with any math class, is to step this up by one. Well, okay, we can find a solution that was a constant, so what's the next most complicated function? Without going way too crazy, I think we should try a solution like y equals ax plus b, that is, try a linear function. Let's see if we can find a linear function that is a particular solution to this non-homogeneous ODE. So I don't know what a and b are, but let's go ahead and work with this anyway. So if that's our guess, y prime would equal ax and y double prime would equal 0. So if we substitute y double prime into here and y prime into here and y into here, if we do those substitutions, then we get 0 minus 4 times a. Excuse me, I had an error here. The first derivative should have just been a. Plus 3 times ax plus b, and we want this to equal x. So this actually sets us up to then solve a system of equations, and this is very similar to the system of equations that we did when we were decomposing fractions by partial fraction decomposition. So notice that if I clean things up a little bit, I'd have minus 4a plus 3ax plus 3b needs to equal x. So I could regroup this way and say 3ax plus negative 4a plus 3b needs to equal on the left-hand side, needs to equal on the right-hand side. Let's write that as a 1x. 1x plus 0. So we have the equations that 3a is equal to 1. That's by this position argument. The coefficient 3a has to equal the coefficient 1, and the coefficient negative 4a plus 3b need to equal 0. So we get the second equation minus 4a plus 3b equals 0. So solving the first, we get a is equal to 1/3. Going ahead and substituting that into the second, we get negative 4 times 1/3 plus 3b needs to equal 0. This gives us negative 4/3 plus 3b equals 0. Multiplying both sides by 3 might be the best thing to do. This gives us negative 4 plus 9b equals 0, or b is equal to 4/9. So we think that our guess y equals 1/3 x plus 4/9 is a particular solution to the non-homogeneous ODE. So let's just check that. So the non-homogeneous ODE was y double prime, lost it, y double prime minus 4y prime plus 3y. We're checking to see if this equals x for this particular solution. Well, y prime is 1/3, y double prime is 0, so substituting this expression, this expression, this expression for y prime and y double prime respectively gives us 0 minus 4 times 1/3 plus 3 times 1/3 x plus 4/9, and we're checking to see if this equals x. So let's see, this gives us negative 4/3 plus x plus 12/9. Does this equal x? Well, I can I can reduce this fraction on the right here as positive 4/3, and so indeed we end up with x equals x. So we know that y equals 1/3 x plus 4/9 is a particular solution. Okay. Unfortunately, WebAssign doesn't ask the right question. I feel like if I asked you what is a general solution to the differential equation y double prime minus 4y prime plus 3y equals x, let me just double check I copied that correctly. The answer would be y is equal to yh, the solution to the homogeneous part, plus yp, a particular solution to the non-homogeneous equation. So then we would say that y is equal to c1. Remember that we were told a while ago that e to the x was a solution. Then I did the work, I didn't prove this, that e to the 3x was a solution as well. So these two together comprise the general solution to the homogeneous ODE. And then we can just add to that a particular solution, which in this case is 1/3 x plus 4/9. This gives the general solution to this non-homogeneous ODE. I hope this was helpful.